Good morning. This is Mr. Cranier. We're covering benchmark number 27. In the last benchmark, we went ahead and we determined if the quadrilateral was a parallelogram. Today, we're going to apply and recognize properties of rectangles, and we're going to determine whether the parallelogram is a rectangle. So I want you guys to go back to your old notes and take a look at the four qualities or the four properties of parallelograms that make a quadrilateral. All right, welcome back. Now we want to talk about the diagonals of a rectangle. So if a parallelogram is a rectangle, then the diagonals have to be congruent. So JL has to be equal to KM. And again, if you're looking at the abbreviation here, if a parallelogram is a rectangle, the diagonals have to be congruent. So again, JL has to equal MK, only for a rectangle. Also, you want to notice that for every single rectangle, you have 90-degree angles. It's going to form those right angles. So angle L, M, J, and K are also 90 degrees. Let me know if you have any questions. All right, this is example number 1. We're going to use the properties of rectangles. So in this construction, you have a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK, oh no, that's okay. All right, this is example number 1. We're going to use the properties of rectangles. Here's a construction. A rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, I'm just going to put that down here in my diagram, and LN is 6.5 feet, we want to find out the measurement from K to M. All right, so my approach to this is that I know some properties of a rectangle. So a rectangle, I know the diagonals have to be congruent to the other diagonal. So if this is 6.5, I know this has to be 6.5. And when I add 6.5 and 6.5, that's going to give me, let's do this, 6.5. Let's multiply all of that to 2. So you get 13 for distance JL. Since JL is 13, I know, based off the properties of rectangles, I know that KM also has to be 13. So if you have any questions, let me know, please. Okay, welcome back. Let's go ahead with this guided practice problem. Quadrilateral EFGH is a rectangle. If GH equals 6 feet, I would again label it. FH is 15. You want to find out what JG is. Right, so take your time, label this. Use the properties of parallelograms, use the properties of rectangles to solve this. Example number 2 on benchmark 27A, use the properties of rectangles and algebra. So quadrilateral RSTU, it's a rectangle. If measure of RTU is 8x plus 4, what's the measure of SUR? And then we want to find out what the measure of x is. All right, so let's go ahead and put this measurement. RTU is 8x plus 4, and then SUR, that's going to be 3x minus 2. And we want to find out what the measure of x is. So we just labeled the angles. Now we know some interesting properties here. We know that the diagonals TR and SU, they have to be the same. We also know this, that for the properties of parallelograms, we know that PT and RP bisect each other. So we know that this equals that, and we also know that SP equals PU. So we know that they all have to be congruent for a rectangle. We know since this leg and this leg are exactly the same, we know the angles have to be the same. So this angle, because it's an isosceles triangle, has to be 8x plus 4. All right. So since we know this angle and now we know this angle, for a rectangle we know it's going to equal 90 degrees. So we're going to go ahead and set this up. Okay, my setup is going to look like this. 3x plus 8x plus 4 equals 90 degrees. And we're going to go ahead and combine like terms here. 11x positive 2 equals 90. Let's subtract 2 on both sides. 11x equals 88. And then let's divide each side by 11. X equals 8. Right, so I'm using some old information to come up with a logical setup, and after you set this up you can solve this. All right, let me know if you have any questions. Bye. All right, this is the guided practice for example number 2, benchmark 27. This quadrilateral EFGH is a rectangle. If the measure of FGE equals 6x minus 5 and the measure of HFE is 4x minus 5, you want to find out the value of x. Now remember some of the properties of a rectangle. Angles have to be 90 degrees. We also know diagonals have to be congruent. And remember the properties of parallelograms, which states that this segment bisects JE and FJ bisects JH. Let's see if you guys get this. Let me know if you have any questions on this problem. Good luck, and talk to you guys later. This is theorem 614. This is diagonals of a rectangle. So if the diagonals of a rectangle, or if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, again, if the diagonals, so W, Y, and Z, X, if those diagonals are of a parallel, if they're the same, then the parallelogram has to be a rectangle. Last example for benchmark 27A. All right, so it says proving rectangular or rectangle relationships. So in art, some artists stretch their own canvas over wooden frames. This allows them to customize the size of the canvas in order to ensure that the frame is rectangular. Before stretching the canvas, an artist measures the sides and the diagonals of the frame. So AB is 12, BC is 35, CD is 12, DA is 35, BD is 37, and AC is 30. Explain, an artist can be sure that the frame is rectangular. All right, so I'll go back to the properties of a parallelogram. One, we know that AB is congruent to CD, and we also know that BC is congruent to AD. So number one, we know it's a parallelogram. And number two, we know that it's a rectangle because AC, that diagonal, is equal to BD. So we know that because AC equals BD, we know that it has to be a rectangle. And we know it's parallelogram based off of AB, CD, and AD is congruent to BC. So let me know if you have any questions on this example. All right, this is your guided practice for example 3. Okay, Max is building a swimming pool in his backyard. He measures the length and the width of the pool so that the opposite sides are parallel. He also measures the diagonals of the pool to make sure that they are congruent. Right, how does he know that the measure of each corner is 90 degrees? So give it a good shot at this one. Make sure you read the questions and the answers here. If you have any question, let me know, please.